Hello everyone. In this video, let's discuss how to delete the middle node of a linked list. You are given the head of a linked list. Delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is n by 2th node from the start using zero based indexing, where x denotes the largest integer less than or equal to x. For n is equal to 1, if the value of n is 2, the index value 1 has the middle element of the linked list. For the value of n is equal to 4, the index value 2 has the middle element. That is what they have mentioned here. So here, if I have the value as n by 2 is the middle element of the linked list. So here I have 7 elements, 7 by 2, 3 is the middle element of my linked list. I need to delete this particular element. After deleting this particular element, the linked list consists of 6 elements, which is 1, 3, 4, 1, 2, 6. Now when I have even number of elements, let's take n value as 4. 4 by 2 is 2. So 0th index, first index, second index. This is the middle element of my linked list. So I have to remove this element. After removing this element, the linked list consists of 3 elements, 1, 2 and 4. Similarly, here I have 2 elements. 2 by 2 is 1. Index value 0, index value 1. So this has to be deleted. Now let's discuss the logic of this program. So here linked list consists of 4 elements. Okay, so we have to write the base condition first. What is the base condition in the sense? If head is equal to null or head dot next equal to null. So the meaning is, if my linked list is empty or it contains only one element, in that particular point of time I have to return null. Why? Because if the linked list is empty, I cannot delete any element, so I have to return null. If the linked list consists of one element, I have to delete that particular element, and we don't have any elements further to iterate, so it has to return null. And one more condition: what if linked list consists of 2 elements? If the linked list consists of 2 elements, the second element has to be deleted. When I am traversing the linked list, I should have only one element. For that, I have to write one more base condition. If head dot next, it states that we have 2 elements in my linked list. If this is equal to null, what I have to do is, I should make head dot next equal to null, which means in the address part of the first node, I'll make it as null, so that I'll delete my second element, and finally I'll return the head value. That's all. Now let's go for the main logic of the program. Here the logic is pretty simple. I'll be taking 2 objects. One is slow and another one is fast. Okay, so here I'm going to iterate slow and fast object. Slow will be moved by 1 step and fast will be moved by 2 steps. So the iteration happens until fast reaches the last node of the linked list. So for that I have to write the base condition, while fast not equal to null and fast dot next not equal to null. The reason why am I writing 2 conditions are nothing but, here we are traversing fast object by 2 steps, which is 2 nodes. So that is why I am writing 2 conditions. Okay, so if the condition is true, what I have to do? Check the condition. Fast is pointing to the address called 1000. Fast dot next is 2000. Both are true. If the condition is true, I have to iterate slow object by 1 step. Slow equal to slow dot next, whereas fast by 2 step. Fast equal to fast dot next. Okay, so slow has to be moved by 1 step, done. Fast has to be moved by 2 step. So first step and second step. Now check the condition. Fast not equal to null. Yes, fast is not equal to null. It is pointing to the memory location called 3000, and fast dot next is 4000. Condition is true. If the condition is true, what should I do? I have to move slow by 1 step and fast by 2 step. So first step and second step. Now check the condition. Fast not equal to null. Condition becomes false because fast is pointing to null. Wherever slow is pointing, that is the middle element of the linked list. Now what I have to do is, I have to delete this particular node. So instead of deleting, what I'm going to do is, I'm going to copy the value and the address pointed by the next node, and I'm going to copy into this particular node, and then I'll delete the next node. I'll repeat. What am I going to do is, instead of deleting this particular node, I'm going to copy the data and the address stored by the next node into the current node wherever the slow is pointing, and I'll delete the next node. So here I want to fetch the next node address. So slow.next is equal to slow.next.val. So here what am I going to do is, I'm going to the next node. So how can I go to the next node? Slow.next will go to the memory location 4000. .val will take the value 4 that I am going to store it in slow.val. Slow is pointing to the memory location called 3000. On the address 3000, the data part is this. Here I am going to store the value called 4. I am going to take this 4 and I am going to store it in this particular place. Next, what am I going to do? I am going to take the next node address part, and that has to be stored in the current node's address part. So slow.next is equal to slow.next.next. So slow is pointing to the memory location called 3000. 3000.next is 4000. Next is null. So this will fetch the value called null. Then where am I going to place? Slow.next. Slow is 3000. 3000.next is this particular place. I'll store the value as null. Done. Finally, what I'll be doing? I'll be returning the head value. That's it. Now, when I traverse the linked list, head contains the first node of the linked list, that is 1000. I'll go to the memory location 1000. I'll fetch the data 1. Okay. Then I'll go to the next memory location 2. I'll fetch the data 2. Then I'll go to the next memory location 3000. I'll fetch the data as 4. So 3 has been deleted. Now this particular node has been deleted. This is the logic of the program. Now let's try to write the code for this particular logic. Okay. So the base condition. So what is the base condition? If head is equal to null, or head.next equal to null, which means if the linked list is empty or it has only one element in the linked list, I should return null. Okay. What if it has two elements? So what am I going to do? I'm going to give one condition saying that if head.next equal to null, I have to make head.next as null and I'll return the head value. Okay. Main logic. So here what I'm going to do? I'm going to take two objects, that is slow and another one is fast. Done. Now I'll be taking a while loop while fast not equal to null and fast.next not equal to null. If this condition is true, I have to move slow by 1 step and fast by 2 steps. Done. Once after iterating, I have to take the next node's address and the data, and that has to be stored in the current node and address. For that, slow.val is equal to slow.next.val. So next node's data part has been taken and stored in the current node's data part, and the next node's address will be taken and that will be stored in the current node's address part. Finally, I'll return head. That's it. This is the logic of the program. Let's run the code now. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.